Thank you, sir. Now, without any delay, I would like to invite our first resource person of today's workshop, Dr. Mohammad Waseem, Assistant Professor at CEWRE UT Lahore. He has done PhD from South Korea and have excellent research background in extreme event analysis, rainfall runoff modeling, and statistical hydrological analysis. Kindly note that question and answer session will be at the end of the workshop. Dr. Mohammad Waseem, sir, please.
Thank you very much. Thank you very much, Engineer Fraz, and thanks to respected Director, sir. Now, I formally start the basic introduction to the watershed modeling. As we know that watershed is the area of land that can contribute runoff to any specific point of interest. As you can see on the right side in picture, here is the land area, and we have the point of interest at the end of the yellow line. If the runoff coming contributing from the land towards this specific point, then the marked like yellow line would be called as its watershed. The main input to the watershed is the rainfall and the snowfall. Other than that, the solar energy for the evaporations. The output of the watershed will be our main output, which is the runoff, and the associated parameters like infiltrations, and if the infiltration goes further to the subsoil, then it is called the percolation, and other is the evaporation and transpiration from the vegetations and the moisture replenishment. There are different kind of classifications available for the watersheds, but based on the area, the watershed is classified into the 5 major categories. Starting from the mini watershed at the end, it's if the area of a watershed ranges from 1 to 100 hectares, then it would be called as mini watershed. Whereas if the area ranges from 100 to 1000 micro and 1000 to 1000 it is called micro. These are classification used to differentiate the different types of the watershed based on the area. The main component, as we discussed earlier, that main component of the watershed is its input. Its input is in the form of the precipitation. So anything falling from the atmosphere in form of liquid or solid is called the precipitation. So the main component of the watershed is the precipitation. As you can see, the next main part is the headwater. The headwater is the area at the remotest point, at the uppermost point where the watershed start contribution it's towards any specific point. Then these water fall on the headwaters, flow through these small tributary streams, and then join to the rivers or major stream at the end at the point of estuary. It's joined at the sea level. The stream networks start from the minor stream to major streams and then converts into the rivers, and at the end it's fall to the sea levels. Other than that, there is the ridge line. Ridge line, as denoted by the dotted line, is the lines which are used to differentiate between two watersheds. After that, there are few more components related to the watershed. Anything within the watershed, lying within the watershed, could be its component like the hill slope, hydraulic structure, floodplains, water bodies, soil, vegetation, land use, land cover, These are the factors that can affect the generation of runoff from the rainfall. So there are different type of process. When the rainfall fall on the watershed, there are different kind of process that take place in the watershed, which is called combinedly called as the watershed processes. The main process of the watershed is the hydrological cycle. As we know that the hydrological cycle summarizes the movement of the water within the watershed. There are four major processes like hydrology, sediment transport, nutrient cycle, and the trophic interaction. The connection between the organisms and the plant is the major factors. We mainly, as a hydrologist, we mainly focus on the hydrology and sediment transport, and whereas the ecologist mainly focus on the nutrients and the trophic interactions competitions. So to process these all, to model these all processes, four processes as we discussed in the last slide, is called the watershed modeling. Actually, the watershed modeling is the category of the models that simulate movement of the water and associated processes. Which are the associated processes? As we discussed, the sediment transportation is the associated process. Its ecology is the associated process, and the and other are the chemical nutrients, and the interaction of the organism within the watershed is also associated process, which is the focus by the ecologist. And the hydrological model, simply as you can see on the right side picture, the is a model that converts your rainfall and associated parameters to the response, that is the our runoff. Here is the simple flow chart of the any logical model. This is the process that from the conversion of the rainfall to the direct runoff. The conversion of the rainfall to the direct runoff is associated with the different losses. The start from the if the rainfall fall on the watershed, it the first minor loss could be the interception and the surface storage. Other than that, the surface storage can cause evapotranspiration, and also if it goes on excess, then it could be converted into the surface runoff, and from the surface runoff there could be also a evapotranspirations. This then surface runoff or surface storage can also cause the infiltration. The movement of the water from the surface to subsurface is generally known as the infiltration, and if the infiltration goes down towards the groundwater, then it is also called the percolation, and this percolation can also cause the channel flow, and ultimately the surface runoff and the channel flow converted into the direct runoff. The every kind of hydrological model, the basic concept is the conversion of the rainfall into runoff, and to it could be the hydrological model could be very simple using the statistical parameters, and it could be very complex using the physical phenomena. The ultimate purpose is the conversion of the rainfall to the runoff. Hence, we summarize that what the model can do. As we discuss, the model can perform the four major processes that is occurring, that is in the watershed. The major is the rainfall runoff, and the second is the sediment transportation, and pollutant loading, steam transport, and management practice can also be done by a hydrological model. It all depend on the type of model that you select and which are the objective of your study. So the selection of the model is mainly depend on your objective. Every model has its specification and its specialization. So before selection of the model, you have to focus on the objective of the study which are you going to perform. So based on different parameters, like time, space, and the process. Time, space, and the process. Hydrologic models are classified into the stochastic models, deterministic models, process-based models, and further the process-based model is classified into the empirical, conceptual, and physical. And based on the space, based on the selection of the watershed, the models are also classified into the lumped, semi-distributed, and the distributed. Here is the some comparison between the different models. As we discussed, based on the process, the watershed models are classified into three major categories. First is the empirical, second is the conceptual, third is the physical. As you can see on the right side, lower right side, here is this simple mathematical relationship between the Q and the precipitation and some the potential retention of the basin like S. So if there is a simple mathematical relationship between linear, non-linear relationship between the independent and dependent, like the input and the output of the watershed. Uh, if I simplify it, then the relationship between the rainfall and the runoff is, if it is in the empirical form, in the simple empirical form, then it lies in the empirical models. And further is the physical. If the you can see on the upper side of the slide, here is the physical process that is being performed in the whole hydrological system. If the models follow all the physical law and equation based on the real hydrological process, then it will be categorized into the physical models. And in between there is conceptual model which use simplified equations that represent water storage in the catchment. So every model have different strengths. Empirical have strength that it used only small number of parameters. Like you can see on the lower right side in the equation, you have only two parameters. One is the curve number and second is the precipitation. If you have curve number, actually the curve number depend on the many factors like vegetation, land use, land cover, and other factors. But here you can see there are only two major input is the precipitation and the curve number. Only two number of input parameters. Whereas in the upper side, you can see there you have to need large number of the process. However, it incorporate the physical phenomena, the actual phenomena that is being happening in the watershed. So the conceptual model actually has easy to calibrate and simple model structures. Weakness of the empirical is that it has no connection, as I discussed. It has no connection between the physical catchment input and the data, whereas physical model have the large number of parameters needed to be incorporated before going to be perform the simulations. Whereas conceptual model do not consider special variability within the catchment. Best use of the empirical is the ungauged catchment, because at ungauged catchment we have very small number of the parameters, known parameters, and the conceptual model is best used where the computational time and data is limited and we need more accuracy and some physical phenomena we have to include. And the next is the physical uh, in physical model you have need a great number of the data. Example is the curve number, artificial neural network. These all are based on the some empirical or statistical formula, whereas the conceptual have some basic programming language like HSPF. It is based on the photon and tau model, HPV and SAT. These are the name of the different models. And physical have some Mike Sheik, VIC, and others. Whereas the comparison between the based on the space, the selection of the models is the lumped, semi-distributed, and distributed. If in lumped model, the whole catchment is considered as a one unit, and whereas in the semi-distributed, the whole catchment is divided into cells, but some cells are combined together. So in a lumped model, series of in semi-distributed model, series of lumped model but combined together is called as semi-distributed, whereas in fully distributed or distributed, every cell is accounted for. Every cell, the rainfall runoff modeling is carried out at every cell of the catchment. Input in a lumped model, you have input only average data of the catchment because the entire catchment is considered as one unit, whereas in the semi-distributed, as we discussed, that it is the combination of lumped and distributed. So you have to put both average and specific data of the catchment. It means you have to put a unit average data of the combined cells, whereas and even single cell also. In distributed, you have to perform all the hydrological process at every single steps. Strength is the that lumped model, as it is in this model, we have to put the average data and the entire catchment is considered as a one unit, so its computation is very fast as compared to the semi-distributed and distributed, whereas represent the strength of the semi-distributed that is present important feature in the catchment as well. And the physical is the all physically related to the, as we every single cell is counted for, then it can be better representation of the physical process and the catchment as well. So weakness is the, in lumped model we have to assume lot of things, as the at every part of the catchment have different could have different specification and different hydrological response. So in this lumped model, we have to assume that all the catchment is have hydrological same hydrological response, whereas the average data in case of the semi-distributed model, the average data into sub-catchment area loss of spatial resolution, as it's did not consider the spatial resolution then. And in case of distributed model, data intense, large number of parameters, large number of the cells are considered, so it is very intensive and time consuming. And the example is the empirical and some conceptual models like machine learning are also included in the lumped model, whereas in the semi-distributed TOR model, SWOT model, and Mike-Shi, other parameters are included in that distributed models. So before going to perform the simulation in the simulation of the watershed, you have these are the basic steps you have to perform. First is the selection of the models. As we discussed that the selection of the model is very important. It all depend on the objective of your study, which you want to perform and which kind of data you have. If you have large number of data and you have all the physical phenomena parameters you have, then you can use the physical modeling. If you have only very limited data, in case of one gauge catchment data, you have to go with the lumped model, or you would go with the empirical models. So first important thing is the selection of the models. Then you have to if you have selected your model, then according to that model you have to select you have to collect the data, input data, then evaluate the objective under the various watershed simulation conditions, selection of method for obtaining basin hydrograph, and calibration, importantly, calibration and validation of the model, and again sensitivity analysis of that parameter, and evaluate the usefulness of the models. Lastly, these are the few model selection criteria as discussed earlier, the assumptions and conceptualizations, ability of model to predict the variables, and the geological process that you need to be estimate the desired output adequately. It could be event based and it could be continuous. Event based means for a single rainfall event, and it could be continuous if you are performing for the large number of the events together, then you can use the continuous process as well. And more importantly, the availability of your input data and expertise available and the price of the models. Thanks a lot for giving me time. Over to Fras. Thank you very much.
Thank you, Dr. Waseem sir, for sharing your valuable